So the first algorithm is the angle-based outlier detection. The basic logic for this algorithm is that the angles between any pairs of points differs widely. The smaller the variance, the higher the possibility of being outlier. Let's look at the figure 1 here. We have 3 data points, alpha, beta, and gamma. And alpha is surrounded by a lot of other data points in the whole data set. So the variance of this data point to any other data is very large. Well, for the gamma here, because it's very far away from the main data cluster, so the variance of this data point to any other pairs of data in the whole data set should be very small, like the figure 2 shows. For outliers, the spectrals the spectrals of the angles is very small, so it's just nearly like a straight line here. But for the outliers, the spectrum is very large. We can see its variance and not. So this is the basic logic for the for the angle-based outlier detection. So in order to calculate this outlier, in order to find out this kind of outlier, they also proposed an equation to calculate the outlier factor, which is measured by the variance over the angles between the different vector of a data point to all the pairs of points in the whole data set, and then weighted by the distance of the point. This kind of algorithm is very robust in high-dimensional data, and it's also completely free of parameters. But the time complexity is also very high because for this algorithm. And then to solve this problem, it also proposed 2 approximations for this algorithm. The first one is the fast ABOD, which uses the pairs of points with the strongest weight in the variance. So it's suitable for the large but low-dimensional data set. Well, another one is the LBABOD, which selects a candidate for the top L outliers and refine the candidate. So this algorithm is suitable for the high-dimensional data set. Besides the original angle-based outlier detection, they also proposed to other authors also proposed to variant for this algorithm. For example, like the simple variance of angle is a novel random projection-based technique, which can estimate the variance of the angles for all data points in a time that's near linear in the size of the data. Another one is the data stream angle-based outlier, so which is suitable for the dynamic data set, and it can also calculate outlier factors very fast without loss of accuracy. So this is all about the angle-based outlier detection. Next one is about the clustering-based outlier detection. So traditionally, the clustering algorithm is mainly used to clustering the whole data set. But here, we can not only cluster in the whole data set, but also identify the outliers at the same time. So the first clustering-based outlier detection were proposed in 2003. The general step is like first we cluster in the whole data set, use whatever the clustering algorithm you like K-means, etc. And then we can identify whether a cluster is a large or small based on 2 predefined parameters. And finally, we calculate the outlier list based on the distance from a single data point to the nearest large cluster. So this algorithm is very straightforward and easy to understand. But the effectiveness is not very high when compared with other algorithms like the angle-based one. And then some other authors also proposed the variant based on this clustering-based outlier detection. For example, like the cluster-based outlier minor, which divides the data stream in chunks and cluster each chunks using the K-mean in a fixed number of clusters. So this kind of algorithm is suitable for the dynamic data set. Another one is the relative outlier cluster factor, which is based on the concept that mutual neighbor graph and the idea that the clusters is the outlier clusters usually much smaller than their normal clusters. So this kind of algorithm can automatically figure out the outlier rate of a database and effectively detect the outliers and outlier clusters without using any parameters. So that's all about this two outlier detection algorithm. Thank you for watching.